Okay, so this is C on the original number 4. And this is a tough question. Out of all the different parts of the free response, this is the one that's going to be worth the most points. And so if we want to find all the input values of M that yield that output value, what we're going to do is set them equal to each other. And if you look back at the notes from this, I think it was lesson 7.2, we did some kind of like this. This one has got some extra stuff that makes it more complicated because it has the square root in it, but you can still do it, but you probably would have needed to look back at it to see what to do. So what we do is first, the side that doesn't have the x, we figure out what that is. So the inverse cosine of 1/2, or the arc cosine of 1/2, is an angle that is going to give you 1/2 as the cosine. And one thing we spent quite a bit of time talking about that day is where those angles come from. So for cosine, the angle is going to either come from quadrant 1 or quadrant 2. If it's positive, it's 100% quadrant 1. So looking in quadrant 1, what angle has a cosine of 1/2? Or it would, if you're looking at the unit circle, it would be what angle would have the x coordinate of 1/2. What do y'all think? Yes, good. So getting that far is probably going to get you a point. I think this one is worth 4 points. So that's the beginning. Everybody can do that because hopefully you'll draw yourself a unit circle and figure that out. All right, now we need to solve this for x. So there's a few steps to do that. So the first thing you would do would be to divide by that 2. Okay. And then we can write this as a tangent expression. So right now it's an inverse tangent, but we can write it as tangent, and we could say that the tangent of pi over 6 is equal to the square root of 27 pi x. And you do something similar for another part. Maybe not. Yeah, you do something similar for a part I. All right. All right, so now we can find the tangent of pi over 6 by going to the unit circle for the pi over 6 angle. The coordinates at pi over 6 are going to be square root of 3 over 2 and 1/2. And when we do the tangent from the unit circle, we do the y divided by the x, or the y times the reciprocal of the x. All right, so those 2's will cancel out, and you're left with 1 over the square root of 3 for the tangent of pi over 6. All right, and now we just need to solve this for x. So we would divide by the square root of 7 pi, which is kind of weird. So when I worked it out instead, I multiplied by the reciprocal of that. All right, so that cancels out over there, and you are just left with x. And then we just have some kind of strange multiplication to do. So when you multiply radicals, if they're both under a square root, you can multiply them together. So when I multiply the square root of 27 times the square root of 3 is the square root of 81. And then at the beginning of this problem, it tells you that you need to leave everything in reduced form. So if it can be simplified, you need to simplify it. And they gave you tons of examples of what they meant. They want you to simplify the square root of 81, which is just 9. All right, so that's 4 points. 4 tough points to get, but you can do it. Just you guys can do hard things. All right, and then I made up a similar one. I don't know if it has the square root, the other one I made up, but the steps are pretty much the same. Do you guys want me to do any other questions on the review? Number one in the multiple choice, or the very first problem? Okay, sorry. All right, so that's something I don't think we practiced a ton. All right, so I'm just pulling up the calculator. It's going to take a second. All right, so for number one, we just have this problem about gravel. And one thing to notice is that the amount of gravel from this function is given in thousands of pounds. That comes into play. All right, and we want to know when the amount of pounds of gravel processed is 6,000 pounds. And so we're going to put that function in y1 exactly like it looks. All right, so inverse sine or arc sine in your calculator is seconds and then the sine. Now we aren't going to do it exactly. We're going to do x instead of t, but everything else is exactly the same. All right. And then we want to know when this function is equal to 6,000, or no, we want to know when this function is equal to 6. We want to know when the amount of gravel is 6,000. Okay. And then we're going to need to change the window because we only care about x's between 0 and 8, or t's basically between 0 and 8. And then our y, we can have the y min be 0 if we want, but we need to have the y max not be whatever I was doing in this last problem, but we want it to be more than 6. So let's just make it 8. All right. And then what we want to find is where these two functions intersect. Yeah, you can just set it on that back table back there. Thanks. All right, so we do second trace 5. First curve, now this can be kind of tricky because right now it's at a point where there's not a value. And I know my x is at 4, so I'm going to move back until I can see this little cursor. Eventually there's going to be a y value. There we go. All right, so I think I told you if there's only one intersection, it doesn't really matter if you move close to the intersection, but it actually does a little bit because there's lots of places where this function is undefined. So anyway, we want to move close to it and then hit enter 3 times. And that should be the answer. 1.69 or 1.70, oh no, 1.695. Oh, it says 6,000. We want to know when it's 6,000 pounds. And then this function is in thousands of pounds. It gives the gravel in thousands of pounds. All right. Any other calculator questions while I'm over here? Yes. Okay, good question. So what you have to do, that's the next one. You do the 4, you do the sine, you do the x minus 1.45. And then you have to do the square on the outside of the parentheses. So that is telling it to square the sine. If you need to square what's on the inside of the parentheses, you have to do that on the inside. All right. Any other calculator questions? Any other questions in general about the review? Yes. Okay. Yeah, they're kind of difficult. Okay. There, I think, is only going to be one vertical asymptote question on your test, but I wanted you to at least be thinking about all of them because it could be any of the different functions. And so if you look at my solutions I posted, I gave you like ways to figure it out. You don't have to have all these memorized. But what you need to know, like for example, if you were doing the one with cosecant of x, so the one with cosecant of x is number 7. What you need to know about cosecant is that it is the reciprocal of the sine. And a vertical asymptote is going to occur when the function is undefined. So if what's going to make the function undefined? Like what makes it undefined? What can you not do mathematically? You get an error. Divide by 0. And so if cosecant is 1 over sine of x, cosecant is going to be undefined when sine of x is equal to 0. And so what I would do if it was me, I was taking this test, I would draw a unit circle at the beginning. And then when I didn't want to know when sine is 0, I'm just going to look at my unit circle. And sine is going to be 0 anytime on the unit circle the y coordinate is 0. And so that's several different places on your unit circle. All right, so then we have to decide what answer choice this is. And these vertical asymptotes are going to repeat every pi units. Now, the only time it's different is if the period has changed, where there's a coefficient on the x and there aren't any. So basically, it repeats every half of the period in this case. For tangent and cotangent, it repeats the period. All right, so our answer choices. Humani. All right, so if I'm getting up here from the unit circle, these are my vertical asymptotes. Which one of these choices matches up with that? That you would get 0 and pi and 2 pi. If k is any integer, yeah, that's going to be a. All right, so that's what I would do. So then when I got to number 8, I would realize, okay, so secant is reciprocal of cosine. I want to find when cosine is 0. And then when you get to the ones like number 10, so this is secant. Secant is going to have a vertical asymptote when cosine is 0. All right, so then if you're looking at the unit circle, cosine is 0 a couple of places. The first one that you see is pi over 2. And so what we do is we take this part that determines the horizontal changes and we set it equal to where the vertical asymptote would be if there were no horizontal changes. And then you're just going to solve that for x by subtracting pi over 3. Now, that's not super easy. To be able to do that subtraction, you are going to need a common denominator, which is going to be 6. So this one gets multiplied by 3. This one gets multiplied by 2. And then in the end, it should be pi over 6, and that's going to repeat every I units. Okay. So go back and try to do those other ones, just thinking in the same concepts of when there would be a vertical asymptote. Because I honestly don't expect you to memorize all the vertical asymptotes. Like, I don't have them memorized. I have to think about it every time. All right. What other questions do you guys have? All right. I'm going to stop the recording, and then if you have something